So when we analyze the figure, OAB is a sector. OAB is a sector of a circle with center O and radius R. AX is the tangent at A to the arc AB. AX is a tangent to the arc AB and angle BAX. Angle BAX is alpha. Our first question is to show that angle AOB is 2 alpha. So our task is to find out angle AOB as 2 alpha. Okay, so when we look at this question, it is comparatively a simple question. So when you look at this question, the first concept what they provided is AX is a tangent to the curve AB. Okay, so here AX is a tangent and AO is a radius through A. So as per the concept we learned earlier, a tangent is perpendicular to the radius through the point of contact. A tangent is perpendicular to the radius through the point of contact. So we can say angle XAO. Angle XAO is a right angle, or which is pi by 2. Okay, and the concept is very clear now, and this angle is mentioned as alpha. So how do we find out angle BAO? Therefore angle BAO. How do we find out angle BAO? Yeah, it is from the right angle delete alpha. We get angle BAO. So we get angle BAO as right angle minus alpha. Okay, but when you look at triangle AOB or ABO, look at triangle ABO. It is an isosceles triangle. Triangle ABO is an isosceles triangle because OA and OB are the radii, which is r centimeter each. So as it is an isosceles triangle, both these angles will be equal as per the concept of isosceles triangle. So we can say angle ABO. ABO also same as angle BAO, and already we got angle BAO as pi by 2 minus alpha, which is same as angle ABO. Angle ABO. Now it is easy for us to find out the value of angle AOB by using angle sum property. So by angle sum property, angle BAO, that is pi by 2 minus alpha, plus angle ABO, that's also pi by 2 minus alpha, plus angle AOB is equal to pi radian. So when you do pi by 2 plus pi by 2, it is pi. Minus alpha is minus 2 alpha, plus angle AOB is equal to pi, or angle AOB is equal to pi transpose these terms to right side, we get minus pi plus 2 alpha. So pi minus pi get cancelled, so that your answer is angle AOB is equal to 2 alpha as our first result. The second part of the question is to find the area of shaded segment in terms of R and alpha. And already we found this angle as 2 alpha. So area of shaded segment, this is a circular segment. So a circular segment is a circular region bounded by a chord and an arc. Region bounded by a chord and an arc is considered as a segment of a circle. So here we have to find the area of the circular segment. So how do you find the area of shaded segment? Area of shaded segment can be found by from area of sector AOB, subtract the area of triangle AOB. So from the whole sector, if you delete this triangle, we get the remaining part as area of segment. Like from the whole segment, if we delete this triangle, the remaining part will be the shaded area, which is equal to area of sector. You know, area of a sector is half r squared theta minus area of triangle AOB, which is a suitable formula, can be used here for finding the area. So when you look at this question, two sides and an included angle is provided. So we can use the formula of half AB sine C. That is half r square sine 2 alpha, which is half r into r sine 2 alpha. So which is equal to half r squared of theta is 2 alpha minus half r squared sine 2 alpha. So you can stop the answer by this, or else even you can take half r square as common. Get the answer as half r squared of 2 alpha minus sine 2 alpha as area of the shaded region. Okay. So when we go through the next part of this question, that is when we go through question B, here an equilateral triangle is given. ABC is an equilateral triangle. ABC is an equilateral triangle of side 4 centimeter. AX, this is X, AX, BX and CX are tangents to the curve or tangents to the arc AC. See, AX is a tangent to AC, BX is a tangent to AB, of course it's a tangent to BC also, and CX is a tangent to BC. Okay. Use the results in part A to find the area of the shaded region. So we have to find the area of the shaded region, and you know the shaded region is this one. You might have got the idea to find the area of this shaded region. It's nothing but area of triangle minus area of three sectors. As each sector has the same chord and it is an equilateral triangle, we may get each sector has the same area. So area of the shaded region can be found by area of equilateral triangle minus area of sector. Not sector, sorry, segment. Segment. And in the previous question, we found to find the area of segment as half r squared, 1 by 2 r squared into 2 alpha minus sine 2 alpha. The previous part of the question, we found the area of segment as this one. Now here, when we look at this question, what is r and alpha? That is one of our questions. What is r and alpha? So we have to find the actual value of r and alpha. For that, let us look at the previous figure once again. So when we compare with our previous figure, alpha is the angle between the tangent and this chord. When you look at here, which is the angle between, suppose we are making this part. So let us make a small construction here. So here alpha is the angle between the tangent and this chord. So this angle is alpha. Just compare both the figure. And we know that angle CAB is pi by 3 radian, or in degrees 60 degrees, because angle in an equilateral triangle, each angle of an equilateral triangle measures 60 degree or pi by 3 radian. So this total angle is pi by 3 radian, so that you can say alpha as half of that. Okay, so we can say alpha is half of pi by 3 radian, or which is pi by 6 radian. So what is alpha? Is pi by 6 radian. Is alpha is pi by 6 radian. Now we need to think about r, radius. This is r. We have to think about r. So how do you find r here? To find r, we already know that this angle is 2 alpha, that is 2 into pi by 6. So 2 alpha is 2 into pi by 6, that is pi by 3. Yes. So to find the value of r, we can use cosine rule. So as per cosine rule, we can say that 4 squared is equal to r squared plus r squared minus 2 into r cos pi by 3, which is 2r squared minus 2r squared cos pi by 3. You know cos pi by 3 is 1 over 2 is equal to 16. So we get 2r squared minus 1r squared, that is r squared is equal to 16, or r is equal to square root of 16, which is equal to 4. So the value of r is nothing but 4. So now we got both the things as 2 alpha or 2 alpha. 2 alpha is pi by 3 and r is 4. So let's find the area of each segment. So area of one segment is equal to half into 4 squared of 2 alpha, which is pi by 3, minus sine 2 alpha, which is sine pi by 3. That's equal to, we get, when you cancel 4 square by 62, which is 8 of pi by 3 minus sine pi by 3. This is the area of one segment. When we are finding the area of all the 3 segments, it is multiplied by 3. Okay, let's find that finally. Now let's find the area of equilateral triangle. Find the area of equilateral triangle. To find the area of equilateral triangle, we can use two methods. One is the direct use of the formula as root 3 by 4 a squared. Area of equilateral triangle is equal to root 3 by 4 a squared. Otherwise, in this equilateral triangle ABC, each angle measures 60 degree or pi by 3 radian. Thus, these two sides measures 4 centimeter each. So we can use even area of triangle using trigonometry as half AB sine C, which is half into 4 sine pi by 3. So we get the result as 8 sine pi by 3. Right? So area of shaded region is equal to area of triangle minus 3 times area of segment. Area of triangle is 8 sine pi by 3 minus 3 times area of segment. 8 of pi by 3 minus sine pi by 3. When we simplify it, we get it as 8 sine pi by 3 minus, when we multiply this one inside, it minus 8 pi. Still when you multiply inside, minus into minus, plus 24 sine pi by 3, which is equal to 32 sine pi by 3 minus 8 pi. And we know the value of sine pi by 3 as root 3 by 2 minus 8 pi. So we get the result as 16 root 3 minus 8 pi. Even you can use its corresponding decimal result also. Okay. When you analyze this figure, you can find out a triangle ABC where AB is 5 centimeter, which is divided into AE3 and EB2. AB is 5 centimeter, AC is 4 centimeter, and BC is 2 plus 1, 3 centimeter. The circles with centers at A, B and C have radii 3 centimeter, 2 centimeter and 1 centimeter respectively, lying on AB and AC and BC respectively. Find the area of the shaded region. So here also area of shaded region is very clear. We can find the area of shaded region by area of triangle ABC minus area of sector AEF minus area of sector BEG minus area of sector FCG. Isn't it? Just think. This is A, B, C, which includes 3 sectors. When you consider this total is the area of triangle ABC. So from this area of triangle ABC, let's delete area of this sector, area of second sector and area of third sector. The remaining area will be our required area. So here we need to calculate 4 areas, which is area of triangle ABC, then area of sector AEF, area of sector BEG and area of sector FCG. In each sector the angle is missing. So our first task is to find out the angle. For that, let's take triangle ABC with sides 3 centimeter, 4 centimeter and 5 centimeter. Okay, to find angle A, let's use cosine rule. By using cosine rule, we can find angle A as like 3 squared is equal to 5 squared plus 4 squared minus 2 into 5 into 4 of cos A, or cos A is equal to 3 squared minus 5 squared minus 4 squared all divided by minus 2 into 5 into 4, or A is equal to cos inverse its value 3 squared minus 5 squared minus 4 squared all divided by minus 2 into 5 into 4. When we do this calculation, we get the value of A as 0.644 radian. So the value of A as 0.644 radian. Similarly, we need to calculate the value of B and C. Like the value of B can be calculated by cos inverse B, its opposite is 4. So 4 squared minus 5 squared minus 3 squared divided by minus 2 into 5 into 3. When we do this calculation, we get the value of B as 0.927 radian. This one, 0.927. Continue the same calculation with C. We get angle C as pi by 2 radian. To find the value of C, even we not required to use this cosine rule. By using Pythagoras theorem itself, we can identify whether the triangle is right triangle, because this is Pythagorean triplets. 3, 4, 5 is Pythagorean triplets which satisfy the Pythagoras theorem. So it is a right triangle. So we got the angles. Now let's find each areas. So first we'll find area of triangle ABC. Area of triangle ABC is equal to, as it is a right angled triangle, as this angle is 90 degree, pi by 2, we can use area of triangle ABC as half into base into height, where base is AC and height is BC, half into perpendicular sides. Even you cannot use that one, you can use area of triangle using half AB sine C, like half 3 into 3 into sine 0.644, anything can be used. And here, as it is a right angle triangle, I am using the formula half AC into BC, which is half into 4 into 3, which is equal to 6 centimeter square as area of triangle ABC. Now let's find the area of each sector separately. So area of sector AEF, the first sector, that is half r squared theta, which is equal to half r squared is 3 squared into theta is 0.644 radian, which is equal to 2.898 centimeter square. Similarly, find out area of sector BEG, which is half r squared, that is 2 squared times theta is 0.927, that's equal to half into 2 squared into 0.927 is 1.854 centimeter square. And the next turn is to find the area of sector CFG, is half into radius is 1 squared into theta is pi by 2, which is equal to 0.785 centimeter squared. So we got all our required areas. Now we can find the area of shaded region, which is area of triangle minus area of each sector, that is 2.898 minus, what is this, 1.854 minus 0.785. Just perform that calculation, we get the answer as 0.464 centimeter square as area of the shaded region. When we analyze this question, this figure, the diagram shows a circle with radius r centimeter and the center O. The line PT is the tangent to the circle at P, so you can understand this angle P, angle OPT is a right angle, and given that angle POT is alpha, the line OT meets the circle at Q. So our first question is to find the perimeter of the shaded region. Express the perimeter of the shaded region PQT in terms of alpha and R. So perimeter of the shaded region is the length QT plus the length PT plus the arc length PQ. Yes, that is the perimeter of the shaded region. So we need to calculate each of these lengths. For that, let us consider the triangle OPT. I'm taking OPT separately. With this is R, this is alpha, and this angle is pi by 2. It's 90 degrees. Okay, so as it's a right triangle, the work is a bit simple for us. To find PT, we can use tan alpha. By using tan alpha, which is opposite side divided by adjacent side, it's equal to PT divided by R. When you cross multiply, we get PT is equal to R into tan alpha. This is the value for PT. This PT. Now let's find OT. OT. OT is the hypotenuse and we know the adjacent side of alpha. So we can use cos alpha, which is adjacent side divided by hypotenuse. So from this we get OT as R by cos alpha. Once we know OT, we can find the value of QT by OT minus OQ, and OQ is R, which is the radius. Therefore, QT is equal to OT minus OQ, OT minus OQ, which is R by cos alpha minus R. This is the value of QT. Now, the last value, so we got QT also. Now we want the arc length PQ. So the arc length PQ can be calculated using the formula R theta, which is equal to R alpha here, because theta is same as alpha. Therefore, perimeter of shaded region is QT, which is R by cos alpha minus R, plus PT, which is plus R tan alpha, plus PQ. PQ is R alpha. This will be the perimeter of the shaded region. The second part of the question is, if alpha is equal to 1 by 3 pi and R is equal to 10 centimeter, find the area of the shaded region. So this is a direct question. Area of shaded region is equal to area of triangle OPT minus area of sector OPQ. So from this full triangle OPT, from this area, delete the area of the sector so that we get the shaded area. And as the triangle is a right triangle, its area is half into perpendicular sides. So half into R tan alpha into R. R into R tan alpha minus area of sector OPQ, which is half R square alpha. Now replace the value of R and alpha. R is 10, so we get half into 10 squared tan pi by 3, because alpha is 1 by 3 pi, same as pi by 3, minus half R squared, which is 10 squared into pi by 3. Just perform this calculation. We get the answer as 34.243 centimeter square. Okay, thank you.